Hi everyone, this is Professor Mayunger and you are watching ERUDIRE Plus, the professional CAD/CAM solution provider. Let's get started.
Hello viewers, today I'm going to show finite element analysis of a cantilever beam under a combination of moment and a point load. Let us see the statement of the problem. Draw the shear force and bending moment diagram for the following beams using ANSYS Mechanical APDL and compare the results. We can see this is a beam of span total 6 meter. It is fixed at location C and we are providing a moment of 80 kilonewton meter at location B, and the point load of 20 kilonewton is applied at location A. We need to find out the shear force and bending moment diagram, and that to be compared with this question paper itself, right? So without wasting time, let us start our analysis using ANSYS Mechanical APDL, right? First of all, we need to create a directory and everything will be saved in that directory. Next to that, we can change the title of this one from file, change title, and we are keeping the name of this title as FA11. Okay, to see the title, plot replot, it will show the title at the lower left corner, right? Now first of all, we need to select what type of analysis it is. It will come from preferences and it is a structural analysis. Okay, next to that, we need to provide elemental properties. It will come from preprocessor, element type, add and delete. We need to add it, and it is a beam with 3D final strain and element type reference number is 1. From options, we can select element behavior from linear to cubic form. Okay, let's close it. Next to that, we need to provide material properties, material models, structural, linear, elastic and isotropic, and we know that modulus of elasticity is 2 into 10 to the 11 Newton per meter square and Poisson's ratio is 0.3, right? So modulus of elasticity is 2e11 and Poisson's ratio is 0.3. Okay, let us close it. Now sections, beam common sections. It is a square cross section of breadth equal to 0.01 meter and height equal to 0.01 meter. So breadth equal to 0.01 meter and height equal to also 0.01 meter. Okay, let us close this one. Now we need to start modeling. Create key points in active coordinate system. So first key point will be created at origin, apply. Next one will be created at a distance of 4 meter, apply, and third one will be created at a distance of 6 meter, apply. This is done. Now to provide the reference key point for the orientation of the beam, let us provide another extra key point at a distance of x equal to 0 and y equal to -4. Okay, done. Now we need to join these key points in the form of lines. So select lines, straight lines. We are selecting key point 1 and 2. Next key point 2 and 3. Selected. Okay. Now we need to mesh it. So mesh attributes, and we need to select the extra key points for the orientation of the beam. So we are selecting all lines and we need to pick the orientation key point also. So let us select orientation key point 4. Okay, done. Now for meshing, you can start with size controls and manual size, lines, all lines, and we are considering numbers of elemental divisions for each line equal to 10. Okay, now finally we can mesh it. Mesh lines, pick all, meshing is complete, right? Next to that, we need to apply our boundary conditions from loading, loads, analysis type, new analysis. It is a static structural analysis. Now we need to define loads from here. Apply structural displacement on key points. It is a cantilever beam which is fixed at this extreme right hand side. So let us select extreme right hand side location. Okay, it is restricted to move in all directions, so selected all degrees of freedom, and displacement of this node should be 0. Okay, so right hand side is completely fixed. Now we need to apply our specific loads, right? 20 kilonewton force to be applied at extreme left hand side. So structural force moment on key points. Let us select first key point. Okay, and it will be in the y directions, Fy, and it is in the downward directions, it will be minus 20,000 Newton or 20 kilonewton. Okay, done. Next to that, we need to apply a moment at any specific location here. So plot lines, you can select the specific location. At this location, we need to apply a moment of 80 kilonewton meter, and it is in the clockwise direction, so it will be negative, right? So force moment on key point, let us select specific location. Okay, it will be along Z, and it is 80 kilonewton meter, so it will be 80,000 Newton meter, and as it is in the clockwise directions, it will be minus. Okay, done. We applied all the required boundary conditions. Now we can solve it. So solution, solve characterless. If everything is right, it will show solution is done. Okay, solution is done, so everything is perfect. We can see our results from general post processing. Okay, so general post processing, and first of all, we need to read results from last set. Next to that, we need to create elemental table. So element table, define table, we need to add it, and we know that for bending moment and shear force, we need to depend on the specific numbers. For bending moment, it will be SMIS 2 and 15, and for shear force, it will be SMIS 5 and 18, right? So we can select by sequence number from drop down menu, and it will be SMIC 2. Apply. Next one, again repeat the process by sequence number, and it will be SMIS 15. Apply. Next one again by sequence number, and it will be SMIC 5. Apply. And the last one again by sequence number, and it will be SMIC 18. First two numbers 2 and 15 are the extreme nodes for the bending moment, and third and fourth, these are the extreme two locations for the shear force, right? Let's close it. First of all, we want to see our results from listing. So list results, and we want to see reaction solution for all items. Okay, let us see that it is 20,000 Newton at node number 22. Now next to that, we want to see shear force and bending moment values from listing. It will be together shear force and bending moment values, right? So elemental table data, we are selecting SMS 2 and 15 for bending moment, and SMS 5 and 18 for shear force, right? Okay, it is having total 20 nodes, and for each node we are having shear force and bending moment values, right? First two columns represented by SMS 2 and SMS 15 will represent bending moment values at specific nodes, and third and fourth column representing shear force values at specific nodes, right? You can see here minimum bending moment is occurring at node number 10. It is 80,000 Newton meter, and maximum is occurring at node number 11. It is 4,000 Newton meter. Similarly, shear force is actually constant for all cases, and shear force, you can see it is 20,000 Newton, right? Next to that, we want to plot results, and we want to see shear force and bending moment diagram, right? So plot results, can do plot line elemental response, and we will see bending moment. So it will be SMIS 2 and SMIS 15. Okay, so you can see the results here itself. It is having minimum shear force at this location, it is 80,000 Newton, and next one you can have here itself, it is in the green zone. Its value is approximately, you can see 35.56 kilonewton, right? We can compare these results with our question paper itself. Let us see that results from question paper, right? It is also showing the same thing. The nature is exactly the same. The minimum is actually 80 kilonewton meter in the downward direction, indicated by minus sign, and here itself it is minus 40 kilonewton meter, right? In our ANSYS Mechanical APDL also we got similar results, right? And you can see here shear force diagram is 20 kilonewton. In the downward direction it is negative, right? Next to that, we want to see shear force diagram, line elemental response. So for shear force, it will be SMIS 5 and SMIS 18. Okay, you can see it is maximum 20,000 Newton. It is in the downward direction, right? So it is negative, right? Next to that, we want to see the animation of this beam. Before that, you need to see the 3D beam. So plot elements, and you can see the 3D from here itself. Plot controls, style, size and shape, and display of elements should be on. Okay, done. Now to see the beam in 3D format, let us see the isometric view or oblique view. You can see this is the beam in 3D format with a specific cross section of 0.01 meter by 0.01 meter, right? Now to see the animation of this one, plot controls, animate, and we're going to see default results. With the default setup, we want to see translation along y direction. Okay, and to see the animation in a higher scale, let us decrease the delay period. So this way the beam will be vibrating. It is fixed at the right hand side, and by the application of moment and also point load, it will be vibrating this way, right? Let us close this one. This is all about our today's video. This was a very simple analysis of a cantilever beam under a combination of point load and moment. In this analysis, we saw the shear force and bending moment diagram, and we validated these results with the question paper itself, and we got the exactly same answer as provided in the question paper itself, right? So with this one, we'll conclude our today's video. Thank you so much for watching this video. Thank you again. Bye.
If you like this video, please subscribe and share. And if you have any kind of doubts, please write to me. Thank you so much for watching this video. Thank you again. Bye.